Ionic compounds in water. So let's see in this video, when ionic compounds dissolve in water, what will happen. So in an ionic solid, the oppositely charged ions are held next to each other by electrostatic attraction. So the positive charge and the negative charge attract each other, the cations or anions. Water separated the anions by replacing that attraction with one between water molecules and the ions. So, when an ionic compound dissolves in water, water molecules separate them and surround them and disperse the ions into liquids. So as you see here, for example, we have this ionic compound. The water is going to surround them and separate them and disperse the ions. For example, the negative part and the positive part, the anions and the cations. So we have the attraction between the negative part of the dissolved compound and the positive part of water molecules. And we have the same thing here. We have the positive compound here and is surrounded by the negative part of water molecules. So although many ionic compounds dissolve in water, many others do not. So it means that we have soluble and insoluble compounds. So soluble compounds dissolve in water, but insoluble compounds don't dissolve in water. So in insoluble compounds, the electrostatic attraction among ions in the compounds remains greater than the attraction between ions and water molecules. So the solid stays largely intact. So it means that when these ionic compounds dissolve in water, dispersed in water, these ions, they do not separate it. For example, it means that the anions and cations still attract each other because they have very strong electrostatic attraction between the cations and anions. So that defines solubility of the ionic compounds. As you see here, the solubility of NaCl in water at 20 degrees Celsius is 365 grams per liter. On the other hand, for an insoluble compound like AgCl, the solubility of AgCl in water at 20 degrees Celsius is 0.009 grams per liter. So the second one is insoluble and the first one is soluble compound. What is electrolyte? A substance that conducts a current when dissolved in water is an electrolyte. Soluble ionic compounds are called strong electrolytes because they dissociate completely into ions and create a large current. So the dissociation or the degree of dissociation is very important to conduct a current, and we can separate them or we can classify them between different electrolyte classes. We will see it later on. One useful property for characterizing a solution is its electrical conductivity, or its ability to conduct an electrical current. So as you see here, we have three examples. We have distilled water, because in distilled water there is no ions, so it is not a good conductor of electricity. So as you see here, the lamp is off. And the second part, positive and negative ions fixed in the solid do not conduct the current. So we have the salt here. So because they are not dissociated, still there is no electricity. And the third one, because we dissolve this ionic compound in water and they dissociated, as you see here in this example, we have the positive and negative ions move and conduct the current. So as you see here, the lamp is on. So it means that the solution is an electrolyte. So we can classify electrolytes based on their degree of dissociation. strong electrolytes, weak electrolytes, and non-electrolytes. So in strong electrolytes we have very high degree of dissociation. In weak electrolytes we have small degree of dissociation, and in non-electrolyte there is no dissociation. Strong electrolytes, for example, hydrochloric or HCl acid solution contains ions that readily contact the current and give a brightly lit bulb. So as you see here, because we have the ionic compound and we have a strong electrolyte, the lamp is on. Second party, we have weak electrolyte. An acetic acid solution, which is a weak electrolyte, contains only a few ions and doesn't conduct as much current as a strong electrolyte. As you see here, the current is very, very low. A non-electrolyte, for example, a sucrose solution, which is a non-electrolyte, contains no ions and doesn't conduct a current. So the bulb remains unlit.